Okay, continuing on with our videos on various logic gates. This video looks at an OR gate. So an OR gate has this circuit symbol, and this is the transistor circuit that will give us this truth table that shows what's meant by the OR function, where we'll get a 1 out as long as at least one of the inputs is a 1. You only get a 0 out when all inputs are 0. And while this is a 2-input OR gate, the truth table holds true for more than 2 inputs. If we had 4 inputs, then as long as at least one of the 4 inputs is a 1, we get a 1 out. We'd only get a 0 out if all 4 inputs were 0. So you can see that this circuitry is different than what we had for the AND gate, and what's different is how the transistors at the input are connected. See, these transistors here, these MOSFETs that are connected at the inputs are connected in a parallel fashion, where if you remember back with the AND gate, they were connected in a series type fashion. So see, just by changing how these input transistors are connected, we get a different truth table. So the next thing, well, before we go and do the analysis like we did with the AND gate, I just want to point out some Boolean algebra, that this plus sign indicates the OR function in Boolean algebra. So it doesn't mean add like it does in base 10 algebra. So the way that you would state this output is that input A is ORed with input B. And again, the OR function is illustrated here in the truth table. Okay, so now let's see where that truth table for the OR gate comes from by doing some analysis. So what's being shown in this diagram is the case where both inputs are 5 volts. Okay, because if both inputs are 5 volts, then the channels for both input MOSFETs are going to be acting like shorts ideally. And when we have shorts for the channels here, it's going to connect this node right to ground. Okay, so it's going to make this node 0 volts, and current's going to flow from this source through this resistor, and the entire 5 volts is going to be dropped across that resistor. So now there's 0 volts on the gate of this MOSFET, which is going to make its channel an open, and when there's an open here, no current's going to flow through this resistor, so there's going to be 0 volts across it, which means voltage the same on both sides, and V out's going to be 5 volts. Okay, which is what's shown in the truth table. Okay, that we see here in our truth table that when both inputs are 1, excuse me, when both inputs are 1, we get a 1 out. Now also the next 2 rows up, you can see that if only one of the inputs is a 1, we also get a 1 out. And that can be explained by looking right here that as long as at least one of these input MOSFETs is acting like a short, that's going to keep this node ground. So you see, whether both are shorts, or whether just this MOSFET's a short, or whether this MOSFET's just a short, as long as one short exists at your input, you know, for your input MOSFET, one of those input MOSFETs, that's going to keep this node ground, and that's going to keep this MOSFET acting like an open from drain to source, and that's what keeps V out of 1. So you're only going to get a different output when both inputs are 0 volts. Okay, because when both inputs are 0 volts, both of these input MOSFETs are going to act like opens from drain to source. So now there's no path for current to flow through this resistor from this source here. Okay, the current will be 0, which means the voltage across this resistor will be 0, which means voltage is the same on both sides. So this would be 5 volts. And with 5 volts on the gate of this MOSFET, it will cause its channel to act like a short, which will connect V out right to ground. Current will flow through this resistor. We'll get 5 volts dropped across that resistor, and V out will equal 0 volts. Okay, so the only time you get 0 volts out of this circuitry is when both input MOSFETs are acting like opens when they have 0 volts on their gate. So that's why this circuit gives this truth table. Okay, you'll get a 1 out as long as one of these input MOSFETs is acting like a short from drain to source. It's only when both input MOSFETs are acting like opens that you'll get a 0 at your output. Okay, so that concludes this video on OR gates, and we will look at a couple of other gates, actually about a handful of other gates in the next video.